All right, so we have some permeable concrete here. So I forgot to mention this the other day when we were talking about the permeable asphalt up at Towers. But regular asphalt has those small stones in the mix, some sort of asphalt binder, and sand. And it all gets heated up and mixed together and they roll it flat. The permeable asphalt leaves out the sand. So it's just the stone and an asphalt binder. So it locks that stone together, but it maintains some permeability so water can go through it. It's the same idea with this. Regular concrete gets mixed up with Portland cement, sand, some sort of stone aggregate, and water. If you've done this before, it's not really too critical. If you're off a little bit on the proportions, you slosh it all together, mix it up, float it with a flat float, right? Let it cure, and in a couple days you're good to go. This leaves out the sand, just like the permeable asphalt. But the proportions are really important. So you have to have enough water to hydrate the Portland cement so that the chemical reaction takes place and it will bond those aggregates together. If it's too wet, it gets too sloshy and it seals off the permeability of it. If it's too dry, you don't get the strength, so it doesn't form enough of a bond to make it strong enough to drive on. All right, so the application of this is much trickier than regular concrete. The application of the permeable asphalt, again, which I didn't mention the other day, is very easy. It goes down with the exact same equipment as regular asphalt. So that's a big advantage of that. This really has to be done by someone who's certified and knows how to put this down. It's very finicky. It has a very long cure time compared to regular concrete. So for those reasons, this lot was initially poured with a whole batch of permeable concrete in the whole thing. It failed over the course of several years and basically became impermeable. All right, it's lost. It started to unravel and the stuff got ground up, and I did testing here and it was not infiltrating any water. So they paved over the center travel lane with regular asphalt just to stabilize it, and we got a grant to put in these permeable concrete precast slabs in the parking areas. All right, so these are all fully cured out, built in the lab. They drop them into the site. So you can't really see it here. If we find it, there are 4 lift points. Here's one. There's 4 lift points in each slab. You can thread a little hook down in there and basically could lift it right out with a piece of machinery. So we can check this and see how well these are doing. This has been in for 3 years now. I believe 3 years. So that's pretty good. It's doing very well. It has been maintained, so we've been maintaining this on a regular basis to keep it free from fines. And so far, I'm pleased with this product. Any questions on this one?
I have one.
Yeah, go ahead.
If this is so hard to apply, why would someone choose to use this over asphalt?
So why would someone want to do this over the asphalt if it's so hard to apply? That is a good question. Some of the, depending on the region in where you have very hot summer, so down south, the permeable asphalt can heat up a little too much in the summer and kind of seal off that surface permeability. So they use the permeable concrete in those situations because it can handle the heat. There's no issue with the heat. So that's one of the main advantages of this product is isn't subject to any heat issues. Many, for the most part in our region, they've modified the binders with the asphalt so that it can handle the heat. So that lot of Towers is doing pretty well for being 11 years old. I would say that this one is, right now, this one is doing better than that one. You saw how fast this sunk in as compared to the other one. But that would be one advantage, I would say. Yeah. Other questions here? All right, shut the video down.